Hello guys, welcome to another video here on command injection under the web fundamentals learning series or learning part. We're currently treating the introduction to web hacking module, and without further ado, let's jump right into it. Now in this module or in this room, we're going to learn about a vulnerability allowing you to execute commands through a vulnerable app and its remediations. Task 1, Introduction. What is command injection? In this room, we are going to be covering the web vulnerability that is command injection. Once we understand what this vulnerability is, we will then showcase its impact and the risk it imposes on an application. Now, then you're going to be able to put this knowledge into practice, namely how to discover the command injection vulnerability, how to test and exploit this vulnerability using payloads designed for different operating systems, how to prevent these vulnerabilities in an application. Lastly, you get to apply theory in practice learning in a practical at the end of the room. Okay, now to begin with, let's first understand what command injection is. Command injection is the abuse of an application's behavior to execute commands on the operating system using the same privileges that the application on a device is running with. Now, for example, achieving command injection on a web server running as a user named Joe will execute commands under this Joe user and therefore obtain any permissions that Joe has. Command injection is also often known as the remote code execution (RCE) because of the ability to remotely execute code within an application. These vulnerabilities are often the most lucrative to an attacker because it means that the attacker can directly interact with the vulnerable system. For example, an attacker may read system or user files, data and things of that nature. Now, for example, being able to abuse an application to perform the command "who am I" to list what your user account the application is running will be an example of a command injection. Now, command injection was one of the top 10 vulnerabilities reported by the Contrast Securities AppSec Intelligence Report in 2019. And moreover, the OWASP framework constantly proposes vulnerability of this nature as one of the top 10 vulnerability of web application, the OWASP framework. Okay, without further ado, let's complete this task. Readme done, complete. Head on to task 2, discovering command injection. Now, this vulnerability exists because applications often use functions in programming languages such as PHP, Python, and Node.js to pass data to and to make system calls on the matches operating system. For example, taking input from a field and searching for an entry into a file. Take this code snippet below as an example. Now, in this code snippet, the application takes data that a user enters in an input field named title. This is the input field title, to search a directory for song title. Let's break this down into a few simple steps. Now, this is of course the beginning of the PHP code and the end of it. And the first line here, the application stores mp3 files in a directory contained on the operating system, right? And that directory is the var.html then songs, right? Now, the user inputs the song title they wish to search for. The application stores this input into the title variable that comes in this code. So third, now the data within the title variable is passed to the command grep to search the title, to search a text file named songtitle.txt for the entry of whatever the user wishes to search for. Alright, so that command is the grep command. Grep command will go into search for that song title in a list called songtitle.txt, right? Lastly, the output of this search of songtitle.txt will determine whether the application informs the user that the song exists or not. Now, this sort of information would typically be stored in a database. However, this is just an example of where an application takes input from a user to interact with the application's operating system. Now, an attacker could abuse this application by injecting their own commands for the application to execute. Rather than using grep to search for an entry in some title.txt, they could ask the application to read data from a more sensitive file. That is where the vulnerability starts, of course, taking advantage of that. Now, abusing applications in this way can be possible no matter the programming language the application uses. As long as the application processes and executes it, it can result in a command injection. For example, this code snippet below is an application written in Python, and here let's just quickly go through it. Note, you are not expected to understand the syntax behind this application, of course. However, for the sake of reason, I have outlined the steps of how this Python application works as well. Now, the first basic command here is the flags package. The flags package is used to set up a web server. So first you set up a web server with this Python code. Then secondly, a function that uses the sub process package to execute command on the device. You set up that particular sub process package. Now the third will be, we can use a route in a web server that will execute whatever is provided. For example, to execute who am I, we would need to visit the http://flagsapp.thm/who am I. So whichever code you want to append, this particular last code here created would use the http://flagsapp.thm. Whatever you append after that should be the command you're using. Now let's answer the questions below. What variable stores the user's input in the PHP code snippet in the tags? In this tags, we remember it was the variable title. Okay, so we're just going to copy this particular variable, which starts with the $, then title. Come here, paste it, and hit submit. Correct. Now, what HTTP method is used to retrieve data submitted by a user in the PHP snippet code is the get request. If you come here, you can see here the $_get. So that's what we use to get or to basically retrieve data from the snippet above. So get, hit enter. Good. Now if I wanted to execute the id command in the Python code snippet, what route would I need to visit? So you see the route would be http://flagsapp.thm and /who am I if you wanted to execute who am I code. But in this case, we're looking at id, so it's going to be the /id route. Sorry, hit enter. That's correct. Let's head on to task 3. Now in task 3 here, we're exploiting command injection. You can often determine whether or not command injection may occur by the behavior of an application, as you will come to see in the practical section of this room. Applications that use user input to populate system commands with data can often be combined in unintended behavior. For example, the shell operator, which is the semicolon, and the double and, will combine 2 or more system commands and execute them both. Just like in Linux system, we use the pipe sign. Like that is, if you're asking the system to execute this command, and then after this command, do the same command right after that. So we use the pipe command, something like that. Now, if you're familiar or if you're unfamiliar with this concept, it's worth checking the Linux fundamentals module to learn more about this. Now, command injection can be detected in mostly one of 2 ways, right? One is blind command injection. 2 is verbose command injection. Now, I have defined these 2 methods in the table below, where the 2 sections underneath will explain this in greater details. Now, blind method. Now, this type of injection is where there is no direct output from the application when testing payloads. You will have to investigate the behavior of the application to determine whether or not your payload was successful. Now, in the verbose method, this type of injection is where there is a direct feedback from the application once you've tested a payload. Now, for example, running the who am I command to see what user the application is running on, that the web application will output the username on the page directly. Okay. Now, detecting blind command injection. Blind command injection is when command injection occurs. However, there is no output visible, so it's not immediately noticeable. For example, a command is executed but the web application outputs no message. Now for this type of command injection, we will need to use payloads that will cause some time delay. For example, the ping and sleep commands are significant payloads to text with. Using ping as an example, the application will hang for X seconds in relation to how many pings you have specified. Now, another method of detecting blind command injection is by forcing some output. This can be done by using redirection operations such as the right arrow. If you are not familiar with this, I recommend checking the Linux fundamentals module. For example, we can tell the web application to execute commands such as who am I and redirect that to a file. We can then use a command such as cat to read this newly created file contents. Now, testing command injection this way is often complicated and required quite a bit of experimentation, significantly as the syntax for commands varies between Linux and Windows. Now, the call command is a great way to test for command injection. This is because you're able to use call means the client URL, if I'm not mistaken, client URL, to deliver data to and from an application in your payload. Now take this code snippet below as an example. A simple call payload to an application is possible for command injection. You have call HTTP vulnerable process and so on. Particularly this code could be able to, you could use that as a payload to check using blind command injection. Yeah. Detecting verbose command injection. Detecting command injection this way is arguably the easiest method of the two. Now, verbose command injection is when the application gives you feedback or output as to what is happening or being executed. Now, for example, the output of commands such as ping or who am I is directly displayed on the web application. Now, useful payloads here, I have compiled some valuable payloads from both Linux and Windows into the tables below. So for Linux, the payload could be who am I, list, ping, sleep, nc. And this is netcat. So now for who am I, this will see what the user application is running under. For list, this will list the contents of the current directory. You may be able to find files such as configuration files, environmental files, which is basically environment files, basically the tokens and application keys and many more valuable things. The ping, this command will invoke the application to hang. This will be useful in testing an application for blind command injection. Now sleep, this is another useful payload in testing an application for blind command injection where the machine does not have ping installed. Now the netcat can be used to spawn a reverse shell onto the vulnerable application. You can use this foothold to navigate around the target machine for other services, files, or potential means of escalating privileges. Now for Windows, the payload could be they share more like who am I, similar for both of them. The description is to see what user the application is running under. We have the dir, the directory, list the contents of current directory. You may be able to find files such as configuration files, environment files, and so on. The ping, this command will invoke the application to hang. This will be useful in helping to test for blind command injection. Timeout, this command will also invoke the application to hang. It is also useful for testing an application for blind command injection if the ping command is not installed. Now let's answer some of the questions. What payload would I use if I wanted to determine what user the application is running as? Is the popular who am I command. Correct. Now what popular network tool will I use to test for blind injection on a Linux machine? We can use ping and we can use sleep, so ping should be the answer for this case. What payload will I use to test the Windows machine for blind command injection? That should be timeout, right up there. Timeout for task 3 and that answers that. End of task 3. Let's head on to task 4. Task 4, remediating command injection. Command injection can be prevented in a variety of ways, everything from minimal use of potentially dangerous functions or libraries in a programming language to filtering inputs without relying on a user's input. I've detailed this a bit further below. The examples below are of PHP programming language. However, the same principles can be extended to many other languages. Vulnerable functions. In PHP, many functions interact with the operating system to execute commands via shell. This includes exec, which executes pass-through system, basically these commands. Now, take this snippet below as an example. Here, the application will only accept and process numbers that are imputed in D form. This means that any command such as who am I will not be processed. So let's just see what that means in summary. The application will only accept a specific pattern of character, the digits 0 to 9, just like we explained in the first command line. The second is the application will then only proceed to execute this data, which is all numeric. Alright. Now these functions take input such as string or user data and will execute whatever is provided on the system. Any application that uses this function without proper checks will be vulnerable to command injection. Another way of remediating command line injections or command injections is input sanitization. Now, sanitizing any input from a user that an application uses is a great way to prevent command injection. This is a process of specifying the formats or types of data that a user can submit. For example, an input field that only accepts numeric data or refuses or removes any special characters such as the forward arrow and the forward slash. In the snippet below, the filter underscore input PHP function is used to check whether or not any data submitted via an input form is a number or not. If it is not a number, it must be invalid input. So we have the filter input gets, it has to be a number. Filter validates number. Now, bypassing filters. Now, application will employ numerous techniques in filtering and sanitizing data that is taken from a user's input. These filters will restrict you to specific payloads. However, we can abuse the logic behind an application to bypass these filters. For example, an application may strip out quotation marks. We can instead use the hexadecimal value of this to achieve the same result. When executed, although the data given will be in different formats than what is expected, it can still be interpreted and will have the same results. More like the payload will be in hexadecimal format, but once it goes in, it will first convert it to the normal value and it will still run the same. Now, answer the question below. What is the term for the process of cleaning user input that is provided to an application? That's sanitization. Sanitization. Z for Americans, and I think Tryhackme is from London, so use S. Sanitization. Sanitization. Ooh. Okay. Correct. Now, task 5. Let's head on to task 5. This is a practical command injection deploy. So I'm going to start this machine quickly and then read through this before it gets ready. Now we're going to deploy the machine attached to this task. It will be visible in the split screen view once it's ready. Now let's see. Okay, now test some payloads on the application hosted on the website, visible in split screen view to test for command injection. Refer to this cheat sheet. Let me open that if you're stuck or wish to explore some more complex payloads. Now find the contents of the flag located in home Tryhackme flag.txt. You can use varieties of payloads to achieve this. I recommend trying multiple. Now what user is, okay, the questions, we're going to answer that soon, and it will be ready in 2 seconds. Let's check out those payloads. I'll scroll down a little bit. We're going to have a lot more payloads here. So there's so much here for Unix, for Linux, Windows, so many payloads. So you can try a bunch of them and let's see. Okay, so I'm going to just show split view, and here we go. So use the handy web application to test the availability of a device by by entering its IP address if the field below, for example. Basically, let's just use that 127.0.0.1. Hit execute and let's see. Okay, I see. So when you execute this, the output is basically it's pinging that particular IP address. That's what this does. So it's pinging this IP address. So let's type that 127, ping that 0.0.1. I'm going to use pipe for this case, and then let's do something like sleep 5. And if it hangs and gives us a result after 5 seconds, that's more like testing for blind command injection. So I execute, and let's see. Okay, here is your command, sleep 5. Okay, looks like it's giving us a result here. So more like use the verbose command injection here, so it shows everything. So I'm going to put in this particular we can test so many things. Pipe, and let's say who am I, and execute and see what happens. And let's see who am I, output www data. So it's just, as I think that's the answer to what user is the application running on. So to test for a user, you just type that who am I. It's quite easy. You can try a lot of options. There's lots of options here, but I'm very much already used to let's just try listing and see if I can see some variable stuffs here. 0.1, and then I like using the pipe, like you should already know. So ls, hit enter, execute. Let's see if I can get some list of things here. Okay, wow, you can see css, image text.php, js text.php. Incredible. You can do a lot of things. You can also use the semicolon pattern. If I hit this, and instead of using pipe, I can just use semicolon to end that particular code, semicolon, and then I can still use that list. No, let me use something else so that we'll be able to use, okay, let me use if config. Let me see if that works. And let's see exactly. So it pings it, but if you scroll down to the bottom here, did it give us a result on if config? I'm not sure if it did that. I'm not sure it executed that. Alright, let's just go straight now and answer the last question here. What are the contents of the flag located here? So usually if I want to pull up the data, I'll just use this. Instead of list, I'm just going to use cat, and then I'm going to copy that particular directory here, Ctrl C, Ctrl V, close that quotation mark or clear that question mark, hit enter. That should give us our answers right away. Should, right? Perfect. So like I mentioned, you can try lots of payloads here that would work. Play around with it, and yeah, so we answered that. We were done with task 5. Let's go to the last task here. I'm going to close this page. Last task here is conclusion. Well done for making it to the end of this room. To recap, we are learning about the following elements of command injection: how to discover the command injection vulnerabilities, how to test and exploit these vulnerabilities using payloads designed for different operating systems, how to prevent this vulnerability in an application, applying your learning by performing command injection in a practical application. As you will have probably discovered, there are multiple payloads that can be used to achieve the same goal. I highly encourage you to go back to the practical elements of these tasks and try some alternative methods of retrieving the flag. Alright, terminate the vulnerable machine from task 5, terminate that, and done. Once you're done, complete that. That's the end of the room for command injection, and thank you for studying with me. Thank you for learning with me. I'll see you guys in the next room, which is SQL injection, which should be the last room for the introduction to web hacking module. I'll see you guys, and make sure you enjoy the rest of your day. Ciao.